Hello, Assalamualaikum warahmatullahi wabarakatuh. Hello my friends, welcome back to my YouTube channel. Okay, today I'm going to discuss about geometric sequences and series. Let me introduce myself. I am Intan Puspita Sari. I'm from Mathematics Education of Professor Muhammadiyah, Dr. Hamka. The purpose of today to explain about geometric sequence and series. Let's get started. Geometric sequences and series. Sequences of number that follow a pattern of multiplying and fixed number from one term to the next are called geometric sequences. Sequences A, for the example, 1, 2, 4, 8, 16, and etc. For sequences A, if we multiply by 2 to the first number, we will get the second number. This will prove any pair of consecutive number. The second number times 2 is the third number. 2 times 2 equals 4, and so on. Sequence B, 16 minus 8, 4 minus 2, 1. Sequence B is a little different because it seems that we are dividing, yet to stay consistent with the theme of geometry sequence, we must think in the term of multiplication. We need to multiply by minus 1 over 2 to the first number to get the second number. This true work for any pair of consecutive number. The 40 number times minus 1 over 2 is the 50 number. Minus 2 times minus 1 over 2 equals 1. Because these sequences behave according to this simple rule of multiplying a constant number to one term to get to another. They are called geometric sequences, so that we can examine this sequence to greater depth. We must know that the fixed number that bind each sequence together are called common ratio. Mathematicians use the letter R when referring to this type of sequence. Mathematicians also refer to generic sequence using the letter along with subscript that correspond to the term number as follows: A1, A2, A3, A4. This means that if we revert to the 10th term of certain sequence, we will label it A1, A14 is the 14th term. This notation is necessary for calculating the term or an of sequence. The R value or common ratio can be calculated by dividing any two consecutive terms in a geometric sequence. The formula for calculating R equals AN over AN minus 1. Note, where n is any positive integer greater than 1. Most greater than 1. To determine any number written a geometry sequence, there are two formulas that can be used. Here is the recursive rule. an equals an minus 1 times r, or an equals a1 times r root n minus 1. In the example, calculate the formula for sequences A seen below and use it to find the ninth term in the sequence. The example in the table, the fixed number called the R value or gamma ratio is 2. The first term A1 is 1. Now we use the Fkip rule to gain a formula. an equals a1 rn minus 1. an equals 1 times 2 n minus 1. an equals 2n minus 1. To find the ninth term, we will simply plug in 9 for the n value and get this. an equals 2n minus 1. a9 equals 29 minus 1. a9 equals 28. And the result, 256. This means the formula is n equals to n minus 1 and the ninth term is 2056. We can look at is a series. As we can see, the only difference between a sequence and a series is that a sequence is a list of number and a series is a sum of number. You can see the formula where Sn is the sum of the first number, a1 is the first number in the sequence r in the gamma ratio of the sequence, and minus 1 greater r greater 1 for infinite series. Let's use example to investigate both formula. Find the sum of the first 7 terms of the sequence. Below you can see the table. The sum formula require use know the first term a1, the gamma ratio, and the number of terms. We know the first term is 1, the gamma ratio is 2, the number of terms is 7. Plug this information into the formula, give us this. You can see the picture. The result Sn equals 127. Thank you for your attention. Don't forget to like, comment, and subscribe. Thank you. Bye.